Thank you. Thank you, Alistair. It's a great pleasure to be back. I must say, Svante Arrhenius is incensed, though. He has 2 food trucks parked in front of him out there. It's a pleasure to be able to talk to you today about this topic. It's been one that's close to my interest for a long time, and I was heavily involved in the establishment of the WMO Sand and Dust Storm Science Advisory and Assessment Program. And I'll talk to you a little bit about that. But today I'd like to really delve into the global cycle of sand and dust, its occurrence, and its impacts broadly, from health to ecosystem to climate and weather. Let me just go along here. First of all, let me acknowledge Ina Tegnan and Kersten Shapansky from Leipzig, who helped update some of the material here with regard to the ice nuclei, knowledge of ice nuclei and climate and dust. And Slobodan Nichkovic, a long-term colleague of mine, who is really he's a specialist in sand and dust, and he worked with me and as a scientific officer at WMO, getting the global assessment sand and dust storm forecasting program going, and I'll explain more later. And finally, all of those who contributed to this the establishment of this operational system, which you can go online and get forecasts for, and there's coordination of researchers in Asia and in Europe and in the Americas with regard to the impacts of dust that we have managed to get them put into place. So, without further ado, global occurrence is, this is a mean picture of the mean aerosol optical depth put together from satellite observations verified by sun tracking, sun photometers. It's all aerosols. Sand and dust aerosols here and here, you can see, are very much part of the scene. We also have biomass burning aerosols, anthropogenic sulfate and organic aerosols, and sea salt aerosols. This picture does not do justice to the pollution of the Arctic in the winter because they can't see the Arctic with satellites very well. But from satellites, you can also use the wavelength dependence of the scattering of sunlight. That's how they measure it, measure this optical depth, to separate, say, the biomass burning in Africa. Here in the easterlies, the plume's coming off, and the biomass burning is mingling with the sand, the African dust in the easterlies headed towards North America, the Caribbean. Just to give you a picture of how it really looks and feels from the ground, this is one of a dust front in southern Israel. Typically, in the eastern Mediterranean, coming out of the Gulf, there is, this is Cyprus, this is the West Bank, Israel here. There's a transport coming off Persia, especially the unrest in the Euphrates River basin from the Iraq war has caused a lot of land surface modification, and there's a lot of dust that comes up, and generally coming up from the Saudi region. And I lived in Cyprus for 3 years. This was a picture in early February 2011 from my balcony looking east, and just a few days later, that's the way it looked as a result of one of those transports. African dust comes off in great masses and is deposited. And this is used, and I'll tell you geophysically in a minute, to look at the history of climate in northern Africa. The atmospheric chemical transport models and climate models and weather forecast models now incorporate the mass conservation equation for dust and aerosols. And from them, and this is one published, very rigorous published account, you can get the deposition, the average deposition. This gives you a picture of the magnitude of dust sources and where they're going, and that Africa and Middle East are one major, right, and then the Gulf. And then you also have the Maclatan-Gobi Desert region of China, more seasonal springtime, March to June. Sometimes flare-ups in Australia, and some off Patagonia, off Western South America. Geophysically, many people here have been involved in coring geophysically, and this is a picture of the dust flux recovered from several cores, and it shows that as you come through the Holocene, about 11,000 years ago, dust deposition to the Atlantic Ocean declined as the Sahel greened, as climate changed in northern Africa, and you went to a savanna climate instead of a desert, and then until about the average here is about 4.9 thousand years ago, it started to get dry again. So there's good use of dust to look at many things. If you turn that picture that I just showed you upside down, here's the you can contrast it with things like this is the temperature cooling. The temperature in the North Atlantic was somewhat cooler at this time, and then during the high dust period, low dust period, we had a warmer period, and then here we have in the Gulf of Guinea, the sea surface salinity obtained from calcium to barium ratios as a proxy, and you can see that the water coming off the sea surface salinity is inverted as well, so it's less saline up here during that period. So there's lots of things that you can do with these particles geophysically, and many people know this. You can look at them in the Greenland ice cores, for instance, to say something about wind-blown dust. And again, how does it feel on the ground? This isn't just a minor problem in some areas. For instance, here is an example of a major dust storm in northwest China that deposited an estimated third of a million tons of sand on Beijing. Okay, there was a famous outbreak in the spring of 2010, just as I was my last year at WMO, when a huge front of Maclatan-Gobi dust came through China, progressively China, Korea, and then Taiwan. And it was recorded in Jinsu province. Dust in Korea reported dust in the air of 2 milligrams, okay, 2.6 milligrams per cubic meter. Well, generally they issue advisories for PM particulate matter less than 10 microns in mass at 400 in the Korean for air quality. Okay, so this is serious stuff, and it has a lot of impacts on many things. Imagine if you're trying to paint in the shipyards, paint a ship. People have to be very aware of the dust conditions. Also semiconductor situations. They have to have closed factories and good clean rooms for their semiconductor. That's the way it looked. And then it swept on across the sea to Taiwan, and it set off alarms in 24 observatories, 1,000 micrograms per cubic. So, and this is moving along over the pollution of southern China, depositing to the sea, transforming, and impacting things. We don't know what it does to, say, things like tropical cyclones but we suspect that, but there is an impact on the glaciation of clouds, and I'll talk more about that later. The occurrence of sand and dust in north of the Alps, this is something people weren't aware of 10, 15 years ago. This is a 7-year record. Based on a 7-year record, the average monthly occurrence of major events in blue. So there's about one major event at Hohenpeisenberg Observatory, not far from Munich, per month, coming up out of the Sahara into the, I'll show you a picture of a major event like that. There's a climatology at Jungfraujoch, Saharan, there's a Jungfraujoch Air Observatory, has a climatology showing here the number of sand and dust events over as a function of month. And, you know, you can get somewhere between 10 events per month, mild or less mild. And you can see this in the glacial ice cores from the Alps. Here's an example of a large transport event in May of 2008 that was recorded by the German aerosol PM10 continuous monitoring network. They got about 100 stations. Huge incursion of 100 micrograms per cubic meter aerosol. Remember, I was talking thousands in the sand and dust earlier from Korea. But that's sufficient for air quality exceedance advisory. And this is the outcome from Slobodan Nichkovic's DREAM model, which he uses the analyzed winds to and the dust storm cycle sources to model. And so, just in summary, there are many impacts. One of them are human health. Okay, various things I'll go through: asthma, upper respiratory infections, problems. I'll talk about these in detail. Weather and climate, marine productivity. I'll talk about that. Transportation on the air and ground. I'll show you a slide I took very shortly. I mentioned industry, agriculture. I took a slide here from the Lufthansa magazine yesterday, showing this picture taken by an Australian in the United Arab Emirates using a drone of the problems that you think we got problems with blowing snow in our country. So imagine plowing this, right? And this is a regular occurrence. Health. This is a picture here showing, it's not very strong, but just bear with me, I'll explain it. This is an air quality particulate 2.5, particle mass less than 2.5 microns, which is one of the regulatory environmental parameters that is measured regularly, and advisories for air quality set based on the levels. This is a model in the University of Arizona in Lubbock, Texas, of this mass event going in this direction. And this is the school absenteeism before and after. It does have a dire effect, and we're talking here of only 160 micrograms per cubic meter. The levels in China event I talked about was 10 times that. So there's lots of impacts, and the question is, what is the global impact of one study that's published here in 2 papers, methodology and the impact paper by Liu et al. From Princeton. I'll explain. They asked, what is the extent of intercontinental fine particle transport? Okay, how much is transported from one continent or one region to another? And then what's the impact? They divided the world up into pieces, various sectors, and they put in various kinds of aerosols, all kinds, okay, fine. And then they used a chemical transport model. They tagged each of the emissions from these regions for sulfur, black carbon, organic carbon, and dust, and they followed it. And they wanted to calculate the premature deaths in each region due to long-range transport of dust. And they did this through this equation here. you take the population on Earth times the fraction of the population. This is for, there is epidemiological evidence for people, adults over 30, which is embodied in this. So they wanted the population of adults over 30, and this is the fraction of the population that's over 30. Okay, so, and then this is the actual mortality, okay, rates. And this is the enhanced concentration of dust in micrograms per cubic meter transported between each of those regions. And this is the epidemiological factor from Pope et al., a very big study done by to establish that there's a 4% increase in adult mortality risk for every 10 micrograms per cubic meter. Okay. So if you do this, they reach conclusion. One, that dust is the dominant component of the intercontinental aerosols, and it comes mostly from Africa and the Middle East, the long-range transport of fine particle dust. And in 2000, this dust was associated with 400,000 premature deaths of adults over 30. And of those 400,000, excuse me, this is all the fine particles, and then 300,000 were from dust. So pollution transport between continents was less important than dust. Now, this is only for PM 2.5 transported between continents. What about people living in the source regions? And there's a nice alert paper, I would say. Acute respiratory infections among children are one of the major causes of mortality in developing countries, but especially in Africa. And there's no studies on the impact of mineral dust on humans in Africa, on children especially. There's so little data. This was published in 2006. Now there is a concerted effort to get more data, but it's still a rather dismal situation as far as air quality monitoring in some of the lesser developed countries. One of the another kind of health impact of dust is this meningococcal meningitis. It is a very serious disease associated, basically 10% of the population carry in the region of middle Africa, or the arid region of Africa, carry this meningitis bacteria in their throats. It's not until it's mobilized into the bloodstream through infections that they get a full outbreak of meningitis. And how is this? There's evidence that very dry air and sand and dust irritation of the throat causing infections is causing flare-ups. Unfortunately, I blanked this out last night. But there were, for instance, epidemics occur. 250,000 cases in 96, 97, and there were mortality of 25,000 people. So this is not nothing to sneeze at. Yeah. Dust, from an ecosystem point of view, dust deposited in nutrient-limited areas. Iron is nutrient limiting in some areas of the oceans. In fact, it's being proposed we should seed the oceans to draw down CO2, right? Off the coast of Africa, the great deal of dust that comes off has been documented to be associated with chlorophyll A and biomass blooms. And people have, Slobodan Ničković, for instance, has put the fraction of iron in the Saharan soil into the source function of the dust. And of the dust models, and then would simulate the movement and estimate the deposition of the dust to the ocean. We need one more thing. One is the solubility, the mobile iron in the dust, and it turns out that dust transported in the atmosphere and processed through clouds becomes, as you move downwind, more soluble. Tim Jekyll's and et al., who did that deposition map I showed you earlier, measured on a ship as you went from Western Africa, very high dust, to lower and lower dust, higher and higher percent soluble iron. They think that's a result of processing in clouds in the middle atmosphere. Okay, so haven't talked much about climate. This is the 2013 radiative forcing chart that you probably all have seen a million times. But let's focus here on the aerosol forcing, okay? And the forcing is basically this. It's the top of the atmosphere. The net flux as affected by clear atmosphere or clear atmosphere with aerosols. Okay, so that's how they get this. And here is a breakdown of the forcing and what they think the different colors here. Mineral dust is here, so it looks like it's mostly cooling due to scattering of aerosols. And then you have sulfates, and you have organic carbon, and you have black carbon, which is absorptive. That's the direct forcing, no clouds. And then this is the indirect forcing. Look at the uncertainties here on both of them, but the uncertainty is very large. A cooling effect here on. Now, dust plays a major role in this through the, and I'm going to talk about dust's role as an ice nucleation, an ice nuclei in the atmosphere. Why is it important? If you form a cloud, you get water droplets. You don't freeze water droplets in the atmosphere at 0 degrees. In the absence of any foreign objects, you can do this experiment on Teflon in a cold room. You can't get ice out of a water drop until about minus 40 degrees. It requires an ice nuclei either through contact with that drop from Brownian diffusion to the drop, or by have an insoluble dust particle condensed upon when you form a cloud in the liquid, and then it freezes, or by direct deposition of vapor. So there's different ways you can form ice. And why is this important? It's important from an energetics point of view. When ice forms in a cloud, if you have a supercooled cloud at minus 20, you have a lot of potential energy to release through latent heat of condensation. If you form one little ice particle, then the differential vapor pressure starts to grow the ice. And then there's other ice multiplication processes, and wham, it goes all over to ice, cirrus cloud, instead of nice fluffy cumulus cloud. Okay? And latent heat of condensation is released. The cloud becomes warmer than its surroundings, buoyancy increases. So a convective cloud, like a thunderstorm, takes off, just energizes. So and rain formation, hail, the whole works is affected. And this trigger is very much dependent on the presence of ice nuclei. And they are very complex in nature. They can be not biological. There's a pseudomonas. This ice nuclei was discovered back in the 70s when I was a graduate student in microphysics and cloud microphysics. This is used in snowmaking on slopes to make sure you don't get ball-bearing snow, but you get real snow crystals falling out of a spray that you put on. Because it's very active, see? You get a lot, this is the activity, the ice nucleation activity. And you can see these aerosols, these bacteria, are very active. But they're not very ubiquitous throughout the whole atmosphere. It turns out that dust, the lower temperatures, dust becomes also very active and other particles. So there's been a lot of research. There's a European project called Bacchus, a 5-year project out of ETH Zurich, a whole consortium studying how you can better represent ice nuclei in climate and weather models. And one of the things that came out of the dust research in the last years, I'll leave this for you to read. It'll be available. Is that K feldspar is a much more ice-active mineral than the clay minerals that people had been talking about earlier in classic cloud microphysical studies. And my colleague Slobodan Ničković points out that this is the distribution of feldspar from the mineral maps that we can put into. And there's plenty, there's lots of K feldspar in the dust regions to mobilize. Okay? So dust is very likely a source of ice nuclei. What evidence is there that it's actually affecting weather or climate? This is a recent study. I think it's very interesting. It's based on the German high resolution forecast model with dust, and they found that there was better reproduction of observed cloud properties, precipitation, with realistic dust concentration. If you included dust, there were improvements. That's the main thing. The problem is that forecast models weather forecast models haven't included dust actively, or aerosols actively, radiatively coupled or coupled to rain formation processes yet. Back in 2003, the British Met Office, Haywood Research Group, had a look at their forecast model and the outgoing long wave radiation over Africa. And then they compared it to the observed satellite outgoing long wave. And they found that there's less outgoing long wave over regions of the desert by 50 watts per square meter than the model has. So they're missing 50 watts per square meter. That's a huge impact on surface temperatures and things, okay? So including that improved the model, basically. But you have to get the dust right, and you have to get the source function right. And you can imagine, as geoscientists, the heterogeneity, the surface conditions are tricky to simulate a source function. I'll talk about that more. Slobodan Ničković put into the DREAM model with Perez and et al. Aerosols in northern Africa. And with no aerosol feedback, he got an aerosol optical depth average in the model of something like this. With aerosol feedback, I mean, you put aerosols in and suddenly you get less dust. Why? There's dust kills dust sort of stuff. Dust is cooling the surface and preventing convection. Convection and more stable atmosphere tends to prevent wind energy from getting to the surface, and therefore you had lower winds. And the source function for dust in these models is roughly proportional to the wind speed at the surface to the power 3.5, okay? Same as sea salt. Surface air, soil type and vegetation and wetness also play a role. But everything else being equal, it's wind speed, very wind speed dependent. Another impact of, this is empirical evidence that during low dust, here is the tropical cyclone days for the North Atlantic. and here's the dust, okay? And they find, this was reported by Evans, and Lau et al. Also reported that during dust period, high dust from aerosol optical depth measurement satellite is associated with less frequent tropical cyclones. Now, correlations are great, but why, right? And the question is it dynamical? Are dust aerosols in the Atlantic just indicators of dynamical situations that don't favor the development of hurricanes and tropical cyclones? Or is there a direct involvement of dust? When I was here, postdoc Mark Chiaccio and a consortium from Stockholm University did an empirical study here, a statistical analysis of the many environmental factors in 6 tropical cyclone basins, okay? And what is the relationship to certain things? We were able to put in aerosol, black carbon, organic carbon, total column, and total aerosol optical depth. And we did find that in the North Atlantic there was a weak inverse relationship between these. So there's evidence, but we don't have the causal connection yet. There's a potential for dust incorporated into tropical cyclone to glaciate a tropical cyclone earlier, and the outcome of that is uncertain depending on where it glaciates and when. Okay, it could actually stop the development of a young tropical cyclone. Now, I had a whole series of slides on dust cycle processes, but I'm just going to talk about one, and that is the role of atmospheric convection and clouds in the source region of the Sahel in producing dust. This is a somewhat obscene little picture here from Peter Kneppert's, but it's cold pools associated with strong convection. Thunderstorms over the Atlas Mountains when the winds impinge from the north on the Atlas Mountains of Morocco. You get tremendous warm air and below and colder air above and strong convection. And you get then evaporation causing cold pools of air to flow out into the northern parts of the Sahara. And this is a satellite picture here showing one of these cold pools. You can see it from the dust. People have sat here in Mali, one study, for 6 weeks at a time and looked at dust fronts coming through and measuring their optical properties. So there's very much concern about that. Okay, so I'm going to end by talking about the WMO sand and dust storm coordination of global observations and the forecast system and what we have and where you can get the information. Forecast models need observations. They are initiated. It's a solution of a differential equation, right? You need to have the boundary condition, the current state of the atmosphere. You get that from observations, okay? You get it from surface-based observations, LIDAR observations, but mostly right now the aerosol forecast models are getting it from satellite observations and verifying from LIDAR and surface-based sun photometer observations. You assimilate these observations into the model and then run a model that has the source function gridded, the transport, the transformation, the deposition, dry deposition, wet deposition. And this consortium was formed in 2007. If you go to this website, you'll find everything you need to know about it, plus the links to the European node in Barcelona and the Southeast Asian node in Beijing, where they're coordinating all the forecast models from each region. There are about 11 or 12 models around in Europe and 3 or 4 in Asia right now. that are contributing to an ensemble forecasting system. And I just went yesterday and picked off one of the ensemble forecasts from 11 models here for the 12th yesterday, 1800, about 6 o'clock last night. This is the situation. There was in Africa, and there was an incursion, if you saw it, into the Iberian Peninsula, headed up into Europe, and one back this way from over in this part of the world. So, sand and I didn't talk to you about sand and dust as a carrier of other things like contaminants. There are evidence that persistent organic pollutants are carried across the Atlantic to the Caribbean, and people measure enhanced deposition of persistent organic pollutants from Western African spraying, that kind of thing. There are fungi carried, valley fever fungi carried on dust in the Americas to Arizona, California, and down into the Andes region that are mobilized on dust and cause valley fever, roughly 200 deaths a year in Arizona, California, due to the breathing of this, and then they get infections and associated infections. So there is evidence that dust has transported other biological material over quite long distances. So I hope that I've given you a feel for what we know right now about sand and dust and some of the uncertainties in modeling. The challenges right now in understanding the role of dust in climate are the source function. It has been established by Peter Knipitz and colleagues that who are dynamic meteorologists, that in order to get a realistic picture of the winds at the surface that are to mobilize dust, you need a grid resolution of about 2.8 kilometers. Today, the ECMWF forecast model globally is at 9, so we're getting there. And the high resolution regional forecast models are down at 5. So we will soon be able to realistically simulate mesoscale winds that are important in Mobileye to get right and therefore get the source function. Once you get the dust into the air, you also have to have the right surface characterization of the dust. You then transport it, and you have to have the right optical properties to interact with sunlight, and the right ice nuclei properties. And the latter are difficult. But at least for the Sahara, where you don't have too much cloud, the non-cloud impacts, I think, are doable. And, so that's where we stand as far as the role of sand and dust in climate and environment and modeling. So I'll stop there, and thank you.
Thank you for the talk. So what is the typical time scale of the sandstorms that they can really persist in the air?
These convective storms are order of hours, several hours in any one spot. They can advect through, they have a life cycle, right? But on the order of, I'd say 3 to 6 hours.
So
yeah, you have isolated thunderstorms, And you can also have pyrocumulonimbus associated with wildfires, which there's been quite a bit of research now on dust mobilized in those.
So in that case, is it the direct or indirect impact on the climate model? Because I'm thinking if the lifetime is so short, and will that have a direct impact on the climate model?
Well, you could see in the IPCC assessment, they had the forcing, and that takes into account the frequency of occurrence of convection. Convection occurs a lot, right, at the intertropical convergence zone, and it's not that far from Africa, right? African dust and Gulf dust. So I think it's quite frequent. Yeah. You know, convection in tropics is very predictable. You have this whole cycle, late afternoon convection, and then it rains, and then you have it the next day, and so on. So I'd say there's enough clouds for aerosols to impact for there to be concern, especially when you get it infected up here into Europe, for instance.
Thanks.
Thank you. One question regarding, for instance, anthropogenic created dust particles. Or you've talked about, like, more or less, I think, natural processes that make dust. But what about, for instance, industry, or what's the scale of these particular matter emitted by anthropogenic sources?
You mean, for instance, from land surface modification?
Yeah, land degradation.
Yeah, land degradation. That's been estimated, for instance, in the Sahel, the overgrazing, and also in the Gobi region. There's been a lot of tree planting going on to reduce that. But I'd say it's for the Sahara, it's less than 15% land surface modification. There's huge areas just open, loose, elevated, and gets a lot of wind. There's I didn't show you, but there's some machine learning algorithms that have been applied to satellite photos of dust over Africa that pull out the source regions, and they're highly heterogeneous and dependent on the geological form, surface types, like loess.
Okay.
Thanks. Thanks for the talk. How do you feel about a possible approach to geoengineering by trying to suppress these sources?
Well, that is going on. There's a lot of tree planting. Koreans have a program of planting trees in northern China and Mongolia, for instance, to reduce the level of what they call yellow dust. Right?
Does it work?
Pardon?
Does it work?
No, not. There's been some evidence that it's reduced in some areas locally up there, but I don't think it prevents those big outbreaks because they're coming from deeper in the desert region than the edge. But it's a nice thing to do.
Hi, Len. Nice to see you. Sorry I was so late.
Hey, Jose.
I couldn't help it. One thing I saw, though, you showed some graph with the number of stations on observation sites, actually, and different things. Do you think it's enough with those and satellites to really understand this problem?
It's a good question. I don't think there's ever enough surface stations globally. There's perhaps too many in some areas and not enough for instance, Africa. Africa, from a meteorological observation, surface observation, and an air quality, is it's a dark hole. You know, there's huge gaps in it. There's 1,500 PM10 stations in Europe, right? And and 500 PM2.5, roughly, just to give. And there's probably 10 or 15 in Africa, all of Africa, that sort of thing. Sun tracking, sun photometers by Aeronet and other organizations are doing a pretty good job, but that in total column aerosol, and that helps verify satellites that pass over twice a day for the MODIS, right, and others, Severi and coming along. But that's total column. It doesn't give you any information about the vertical distribution. LiDAR networks are coming, and the European infrastructure project, ACTRIS, with its surface-based observatories and LiDARs, I think will be filling a huge gap there. And hopefully some of it will spill over into the lesser developed regions of the world where we have most of the dust.
So given the current knowledge on how dust can affect health, and also given that the last glacial period was quite a lot drier than it is now, has there been or will there be any research on sort of hominin evolution and migration and how dust might have affected that?
I don't know. That's a good question. I think that would be the best way to say.
Maybe there will be.
Yes, hopefully.
I think you mentioned briefly that it was difficult to measure aerosol or the sources of dust in the Atlantic. Or you just mentioned something that the satellite data is not very good from that area. Is that right?
Well,
I'm thinking about more northern latitude sources of dust. And if you have anything to say about that, we saw mostly more lower latitude sources.
Northern latitudes, there's certainly dust, Icelandic dust occasionally, but on the larger scale for the magnitude of climate, the Saharan and the Gulf and the Middle East dust far outweighs, I think, that.
So it's
there's some reticence, I think, on the part of agriculture organizations to characterize mobilization of dust. It can, in arid regions like the West, I lived in Washington State for 3 years. Eastern Washington State, over the mountains from Seattle, is savanna climate. And there's a lot of wheat growing and vast fields, winter wheat. And in the summer, and certain times of year, the fields are bare. And mobilization of dust was very evident there in high wind periods. But the Environmental Protection Agency of the U.S. had no interest in dust from PM from dust and interacting and controlling agriculture industry, right? So there's a lot of effort in agriculture to control dust for erosion purposes, right? There's planting strips of fields with trees in between to keep the winds down so you don't get the erosion, that sort of thing.
Thank you.
Hi, Len. Also thinking about the sort of historical paleo record, to what extent are lake records or something like that used to try and, or even offshore Atlantic records, core records used to get some help map the extent of dust transport? Is it something that's being integrated on sort of past time scale or even current, really?
I think it's being used in our paleoclimate models. That's the main area. The core data
Yeah,
from
absolutely.
the coast, right?
Yes, and because there should be a very clear sort of drying of Africa story
Yes.
in
Definitely.
the dust and recorded offshore somewhere. But I don't know, even in the shallower sediments, is it being used as a mapping tool? Maybe not very well.
Yeah, probably not. Of course, shallow sediments are subject to disturbance too, right?
Yeah.
More so.
Yeah.
So, but they're certainly with the paleoclimate modeling, I'm sure.
Yeah.
They use everything they can get, and there isn't much, and so cores are very extremely valuable. But I don't know of too many dust records. You people, Marlene probably knows more about that than I do.
I can take one more question. I think that Svante has already grabbed it.
I just want to say that there are records tracking the westerlies from marine cores and lake cores with dust particles. So that's something that is frequently used.
And which lakes?
You can do it in any lake. And you can do it in peat bogs, which has been done also. But in the grand scale climate patterns have been using marine cores to track the southern westerlies and the northern westerlies.
Or maybe a comment. Right?
I just wanted to comment about the paleo aspect, that there's an effort to actually compile atmospheric records. So they use offshore, like marine cores that don't take in continental sources. And then we also use ice cores and loess and then peat bogs. But the problem is that something like 70% of dust is actually deposited on the continents. And there's an overrepresentation from the marine cores. So we actually probably don't have a great paleo picture of what's happening on the continents. So that's why we're trying to develop new archives for the dust deposition. Mm-hmm. So there's a concerted effort to compile and use these paleo archives in the paleo dust modeling. But I think it's probably quite hard to transition those forward or to the present day. But probably, as you said, for doing the paleoclimate modeling of the dust.
Thank you all very much for lots of really fascinating questions. I can already hear a potential collaboration between research areas 2 and 5 and 6 germinating in this session. It's been a fantastic pleasure having you, Len, here to give a talk with us today. If you wait 1 second, I think our co-director of the Bolin Center, Nina Kirshner, wants to come up.
Thank you for joining us today. I also hope that you can stay on because we have another seminar at 2 o'clock. So if you have a chance, this is hosted by Research Area 8 at 2 o'clock. I think, I'm not sure, Annika, in the same room? Yes.
And the topic is?
On the woolly mammoth.
Aha.
There's probably some dust also involved.
Yes,
really.
yes.
Yes.
It's very woolly.
Yes. So we have a little present for you here as well. Maybe you already have everything, but in case you need to look something up on the center, here is a kit for you.
Thank you.
And welcome everyone for the sandwiches, lunch sandwiches outside. And thank you very much again, Leonard.
Thank you.